Everybody, Mr. Smith here, and in this video lesson, we're going to review some of the things you learned in your grade 9 course in the Analytic Geometry unit. So specifically, that'll be finding the slope between two line segments, so developing a formula for that, then how to find the equation of a line algebraically given information about that line. So let's get started. I should say also, we're just going to quickly talk about what you guys learned about parallel and perpendicular lines. So let's not beat around the bush. Let's dive right in. So in grade 9, you developed a formula for finding slope because, given 2 points, it wasn't always easy to say sketch the points and just like visualize the rise and run if you're working with large numbers or fractions or decimals. So in general, if you have 2 points, and I'm going to call this guy point 1, I'll say it has coordinates x1 and y1. And this point up here, I'm going to say it has coordinates x2 and y2. So each point has an x and a y. This is point 1. This one's point 2. And what we're interested in finding is a formula for the slope between them. So I'm going to add something to my diagram here, just very rough. I'm just drawing a vertical dashed line and a horizontal one. So this is going to represent the rise, and this is going to represent the run. And so we'll leap off from there. So far in this course, we have talked about slope, and we've talked about slope being rise over run. But if we think about what each of these means, actually, the rise is the, if we look at the y values, the rise is the difference between the original y value and the remaining y value, the second one. And to get the difference between two numbers, you subtract. So the rise is given by the difference in the y values. You take the second y value and you subtract the first. That gives you the rise. And in a similar way, you can find the distance between the points horizontally by looking at the difference between the two x values. And this is your classic slope formula, which you developed and were probably expected to know and be able just to use in grade 9. Having reviewed it now in this course and moving forward, the slope formula is one of those formulas you're just kind of expected to have in your math toolbox. So rise over run gives you y2 minus y1 divided by x2 minus x1. So let's just get back into the swing of things. Can you find the slope of the line segment joining the following points? So using our re-derived formula, y2 minus y1 over x2 minus x1. If you want to give that a try. Maybe you want to walk through the first one with me. Let's do it. So at least for the first one, I'll write out my formula. In practice, you don't need to if you're getting comfortable. But I usually take my 2 points in questions like these, and I'll just above them label them. Okay, that's my x1, y1, and this is my second point, x2 and y2. And then I see everything I'm going to plug in. y2 minus y1, that's 8 minus 3. x2 minus x1, that's 17 minus 2. That gives me 5 over 15, which is completely right. However, we should be getting used to putting things in as simple as possible. So in lowest terms, that is 1 over 3. And that's the slope of that line segment. Let's try the next one. Again, you don't have to write the formula down every time, but for some of you, it might just help you get organized and collect your thoughts. You don't have to write x1, y1, x2, y2, but it could help. Certainly can't hurt. Maybe the last one I won't. See how we do. Yeah, let's plug in what we know. So y2 is -2, and we're subtracting, and then just be careful, we're subtracting, excuse me, gotta be careful there. We're subtracting 8. We don't need the double negatives. y2 minus y1. y1 is 8, not negative 2. Yeah, negative 2 subtract 8. And on the bottom, x2 minus x1 is 4. And here we have to be careful. We're subtracting, and x1 is negative 2. So you just need to be careful with signs. So here we get on top, negative 10. On the bottom, 4 plus 2 is 6. And then we should write that in lowest terms. We get negative 5 over 3. We have the slope of that line segment. Maybe you can try the last one on your own. Pause and unpause the video. So I think we'll have a little talking point with this one afterwards. All right, so maybe this one I won't write down the slope formula, but maybe I'll still label my points. That can always be helpful. So y2 minus y1, 0, subtract 0.5. And for the run, x2 is 2.5, and we're subtracting negative 5. So what do we get? We get negative 0.5, and 2.5 subtract negative 5. That is positive 7.5. Now that is correct. However, usually we like to write our slopes as a rational number, a fraction, with one number divided by the other. So an easy way to do that with this one is to multiply that fraction by 2. Multiply the top and bottom by 2. You get negative 1 over 15, which would be easier to graph. Just makes more sense. It's just good form to write them in terms of our fraction. All right, so now we've reviewed the slope formula, and we've done 3 examples. So if it was a while since you used it, we're kind of now got back in the swing of things. And so as we do problems that require slope, we can work through them a little bit faster now, hopefully. Let's continue. A part of the grade 9 course was working with linear relations, and then learning about what makes lines parallel and what makes them perpendicular. So parallel lines, we've all been working with parallel lines for a long time. Kind of go off in the same direction. We often use these double ticks for the double arrows for parallel lines. But for lines to be parallel, they have to have the same slope. Now that's pretty intuitive. And then in your grade 9 course, you investigated. I often spend just a whole day just kind of looking at this, but you would have looked at the slopes of perpendicular lines and asked, well, what's the relationship between those guys? And you would have came to this conclusion that slopes of perpendicular lines are negative reciprocals. What do negative reciprocals mean? So, for example, take 2 over 3. Reciprocal means you flip, and negative implies you take the opposite sign. So the negative reciprocal of positive 2 over 3 would be negative 3 over 2. You flip it and you change the sign. In a similar way, say you had negative 4 over 5. The negative reciprocal of that would be, well, you flip it and then change the sign. So instead of negative, it would be positive, and that you'd have 5 over 4. So in this table, I just have a small exercise for us to do. Can you pick off the slope of each line? State the slope of a parallel line. So if a line was parallel to that, what would the slope be? And if a line was perpendicular to that line, what would it be? And maybe I should add too, if you forget what perpendicular means, perpendicular is another word for a right angle, so 90 degrees. Okay? So you can pause the video and try those if you want, or you can follow along with me now. The slope of this line is 2/3. It's in y equals mx plus b form. We can read it off. Remember that parallel lines have the same slope. So a slope of a line parallel to this one would also be 2/3. And it looks like I've kind of spoiled the game because we've already done that as an example up here. A line that's perpendicular would have a slope of -3/2. What about the next one? Slope of -2. A parallel line would have a slope of -2 as well. But what would the negative reciprocal of -2 be? Because -2, as it's written there, isn't one thing over another. So how can we do that? Well, you could think of -2 as -2/1. So the negative reciprocal to that, I might even just write that's the same as -2/1. That's not fully simplified. We would never leave something like that, but it's going to be instructive for us. The negative reciprocal, you flip, so 1/2, and it was negative here, changed to positive. The very last one, if you tried it, I threw in there as a little bit of a curveball. It's a special case we have to consider. The line y = 7 is a horizontal line. It has a slope of 0. It doesn't have no slope. Its slope is 0, because that's like 0 times x plus 7. A parallel line would also have a slope of 0. But what is the negative reciprocal of 0? That's a little weird, because one doesn't have a 0. It doesn't have a sign. It's not positive or negative. And if I say write 0 as 0/1, well, when you flip that, you get -1/0, which is weird, because you can't divide by 0. So instead, we say that the slope of a perpendicular line is undefined in this case. A slope of 0 is a horizontal line. A line with undefined slope is a vertical line. So it's just one special case where the negative reciprocal idea, you can still use it like I did, turning 0/1 into -1/0. But we usually just say 0 for horizontal and undefined for vertical. All right. So the next thing we're going to do is we're going to review how to determine the equation of a line algebraically. Now, I said in this slide here, in a normal classroom, we do this unit over the course of 2 or 3 weeks. So, with right now, the way we're condensing the class, it might be a week plus. But an important skill for us to have is going to be, can we make an equation of a line given certain information? Because we're going to be looking at really interesting properties of triangles and quadrilaterals, and we're going to need to be able to find equations of lines. And this is where the work you paid off in grade 9, or the work you did in grade 9 pays off. Because in grade 9, you do this, and we're reviewing it right now, but you didn't always get the benefit of seeing how it's going to be useful, and now we're going to be able to do that here. But the strategy is always the same. I've listed it there. It's literally the same process every time. You get the slope of your desired line. If you're finding the equation line, you get its slope. Some way or another, you figure out what its slope must be. And then we use that slope and a point on the line to find the y-intercept. And it's the same process every time. So let's review how it works. And for each of these guys, we're going to draw a little visual. It's not always practical to draw a visual, and we're going to draw. Sometimes that'll give us the answer, but we're going to do it algebraically too. So we're looking for the equation line that goes through the point 6, 1 and has a slope of 1/3. Let's just literally draw that out. There's 6, 1. Go up 1/3. There's 1 point. And go backwards too. If you go, looks like I went down a little bit too low there. Down 1, left 3. Down 1, left 3. We can actually see that the y-intercept for this line is -1. And we got it by graphing. So we actually kind of already know what the equation should be. It should be y = 1/3 x minus 1, because the y-intercept is -1. Now, graphing isn't always practical or possible. So let's actually do this problem algebraically and show that we get the same answer. So this question was a nice, easy start, because we are just told that the slope of our line is 3. So if you want, you can start with, okay, I need my equation in y = mx plus b form. And the question just told me the slope. That's good. That's half the battle. How do you find b, the y-intercept? The strategy is always the same. You will always be given a point, at least one point, every point has an x value and a y value. You can sub those into your line. The question says that when y equals 1, x equals 6. And this gives you a tiny equation to solve for the y-intercept b. 1/3 of 6 is 2. And 2 plus what number is equal to 1? You can subtract 2 from each side. We do, in fact, get b equals -1. And the equation of our line, as we wrote on the side that we found graphically, is this, 1/3 x minus 1. So in practice, you might not always have a graph, and you'll have to be able to do this algebraically. Now, a good thing these days with you guys, you have programs like Desmos where you could check any of these questions. You could check by plotting it in Desmos. Let's continue and do another example. We're going to be kind of ramping up in difficulty as we go. So here, we're given a line, 2x plus 3y equals -9. And we're asked to find the equation of a line that's parallel to that line. So it's not that line, it's parallel to it. And it also goes through the point 5 minus 3. So 5 minus 3 is down here. And right now I can't really draw more on my diagram because I actually don't know what this line looks like. So I'm actually going to draw this line. And I'm going to do that by I'm going to do some rough work up here. Remember, to get a line into y equals mx plus b form, you can do some rearranging. So we bring the x term over, and then we'll divide everything by 3. So we get y equals -2 over 3x, and -9 divided by 3 is -3. So let's plot this guy. Y-intercept of -3, down to right 3, down to right 3, down to right 3, and back up the other way. And for this one, ooh, yikes. Not an amazing line, but it's going to do for our purposes here. We're asked to find the equation of a line parallel to that one, but it goes through 5 minus 3. So we can actually draw this one out, right? Because a parallel line, remember, parallel lines have the same slope. So down 2 over 3, if we add more points, down 2 over 3, down 2 over 3, down 2 over 3, we can see why we kind of need algebra. Because that y-intercept isn't at a nice whole number. This was 5, -3. That y-intercept is not at a whole number. It looks like it's between 0 and 1, but it's impossible to read off by making a rough sketch like we did. And I'll stress the word rough there for sure. Luckily, though, we have an algebraic way to do this. So let's get after it. Never a bad idea just to get your mind settled in. Just write out the equation of a line. This is what we're going for. And we know the slope. Our line is parallel to this line, which has a slope of -2 over 3. But we currently don't know our y-intercept. We know it is around, it's between 0 and 1. Let's use our same strategy. When x is 5, y is -3. We know that y is -3. When you plug in x equals 5. And now we solve this equation. If you don't prefer working with fractions, no problem. Do you remember our strategy for working with fractions? We multiply everything by, in this case, 3. We'll get -9. And then 3 over 3 is 1, so it's gone. -2 times 5 is -10, right? The 3's divide out. And then plus 3b. And this is a little two-step equation, not too bad to solve. Add 10 to each side. We get that 1 is equal to 3 times b. And dividing both sides by 3, you get that b is equal to 1/3. And so the y-intercept of our line is actually at 1/3, or like 0.3 repeated. So we're done. The equation of our line, y equals -2 over 3x plus 1/3. We got that using algebra. That would have been impossible using just from a graph. It's too hard to visualize. So that example built on the previous one, here we actually had to rearrange an equation so we can see what its slope is to determine a parallel slope. Let's look at another example. So this one, in my opinion, is not probably as difficult as the previous one. So we have a line joining the points -6, -7, so way down here, point A, and 9, 3, which is up here. Now, because I can't do a straight line with my PowerPoint program, I'm going to do like just a rough dashed line. So we want to find the equation of that line. So we don't know the slope, and it looks like our y-intercept could be somewhere around -3, maybe. But let's find out. So if you recall on a previous slide, I said our first step is to determine the slope. So in example 1, the slope was given to us. In example 2, the slope was not given to us, but after we rearranged the equation of the line given, we could just read out the slope. It's parallel, so the same slope. How can we find the slope in this question? Well, fortunately, we reviewed an equation that helps you find the slope between 2 points. That's the slope formula. Let's use it. x1, y1, x2, y2. So y2 minus y1 minus 3 minus 7. And then 9, subtract -6. We get on top 10 over 15, which simplifies nicely to 2/3. So let's double check. Does that seem reasonable? Let's start at point A. Go up 2 over 3. Point. Up 2 over 3. Point. It fits perfectly. And actually, it looks like our y-intercept is -3. Let's show this algebraically. So we want the equation of the line y equals mx plus b. And we just found out the slope is 2/3. How do we find b? Same way every time, you plug in a point. And which point do you want to use? It's up to you. I think I'll use b because all the numbers are positive. I know that I get a y value of 3 when the x value is 9. And let's solve for b. Now, like in the last question, I had to clear some fractions to solve for b because -2 times 5 over 3 didn't give me a whole number. Do I need to clear the fractions in this case? No, I don't. 2/3 of 9 is exactly 6. And it is 6 plus -3 that gives you 3. So we've got it, guys. The equation of our line in this problem that passes through those 2 points is y equals 2/3 x minus 3. So we worked through it visually and also showed how to do it algebraically. But it's ultimately, guys, it's the same step every time. It's find the slope somehow, plug in a point to find b. I believe I have one more example to do with you guys. We're going to find the equation of the line through the point 1, 1 that is perpendicular to this line, x minus 4y equals 7. So in a similar way as example 2, we've got to work to get the slope. It's not given to us and we can't calculate it. We know it's perpendicular to this line. So let's find the slope of this line here. We can do that by just doing a bit of work, rearranging it into mx plus b form. So that's subtracting x, adding 7. And if I divide everything by -4, I get y equals, that's -1 over -4. That's the same as 1 over 4, x. And I get -7 over 4. Now that might be impractical to graph, but we don't care about the graph, right? All we care about is the slope of this line. So the slope of this perpendicular line is 1 over 4. What would the slope of our line be equal to? Remember, perpendicular slopes are negative reciprocals. And if you're wondering, that upside down T is just a symbol I use for perpendicular. So remember, negative reciprocals. What's the negative reciprocal of 1 over 4? Well, it's flip, so 4 over 1, or just 4, but negative. The slope of our line is negative 4. And we are given a point, 1, 1. Plug in 1 for y. We are told that that happens when x is 1. And we can solve for b. Negative 4 times 1 is negative 4. Add 4 to each side. B equals 5. And the equation of our line negative 4x plus 5. Now, here's a good talking point. That line we had here, not exactly practical to graph by hand. So why don't we actually toss in Desmos into this question? So I'm going to graph this line, x minus 4y equals 7. And I wonder if I can do it. X minus 4y equals 7. Does it do it? It does. Man, Desmos is amazing. See that? You could actually plug in this form and it plots it for you. So remember our slope was 1 over 4, but the y-intercept was negative 7 over 4. So that's about negative 1.75, which you can see right here. Let's go to the next line. Can I plot the point 1, 1? I believe I can. Oh man, this is amazing. And I can label it. Guys, Desmos is the real deal. And now let's graph what we think the answer is. So we think the answer is negative 4x plus 5. Have a look at our line. Is it perpendicular to the original line? It definitely looks like it is. Does it pass through 1, 1? Yes, it does. So we did the question right. And you guys can have Desmos open at home and be checking all of these as well. And it's a great to consolidate a problem and visualize the answer to wrap things up. Awesome. So those are 4 examples of finding the equation of a line, kind of ramping up in difficulty. This is the level of problem that we're going to have to do. And for some questions we might have to find 2 or 3 equations of a line. And we just have to get to a point where we're proficient with it, where it doesn't take 10 minutes per line, where we understand the process and the system, and we can just go at it systematically, find the slope, plug in a point, get the equation. Find the slope, plug in a point, get the equation. And just get really, really just get better so that we're not spending a ton of brain power on it. What we're doing next, so with that little bit of review of finding the equation of a line, we're going to start our unit on analytic geometry. So in grade 9, you guys determined a formula for the slope of a line segment, which we reviewed in this lesson. In our next 2 lessons, we're going to get 2 new formulas, one for length and one for midpoint. Our next lesson is actually on the midpoint of a line segment. How do we find it? What's the formula? What are some uses of it? It should be pretty fun. But until then, hope you guys are staying well. Have a great day, and we'll see you soon.